Hello all, so this is still 9.2. Now that we're done looking at the pictures, we're going to deal with equations. So as you can tell from the front of this page, every answer either dealt with infinities or we had to look at an asymptote, maybe a side-to-side asymptote or an up and down asymptote, but either way we dealt with asymptotes or infinities. Okay, so that's what we're going to do with equations. We're going to talk about asymptotes and infinities and all that stuff. Okay, let's see. First off, how to find a limit of a rational equation as x approaches a number. So this is what we did in not 5.1. This is supposed to say 9.1. I keep doing that. Yeah, okay. So anyway, in 9.1, we learned that you just plug your number in. So let's try this for this little baby example. If I plug in -4 to the bottom, I get 0. And that's bad. So if you get a 0 in the denominator, we were supposed to factor, cancel, and plug in the x value again. Okay, so let's try factoring this. If I were to factor this, I don't think I left enough room. Okay, I'm gonna do it up here. Woo. My bad. Okay, let's try and factor this. The bottom has an x, so he's pretty much factored. In this class, we pretty much only worry about if there's an exponent in the air. So on the top, there's an exponent of 2. And there's 2 terms, there's a minus sign, and I see a square. So that's that difference of squares. So we're gonna draw 2 sets of parentheses, slap some x's at the front, put a minus and a plus, and then we ask ourselves what multiplies with what to give you 16? 2 and 8. No, we have to have the same 2 numbers because it's a difference of squares. So what 2 of the same numbers multiply to 16? 4 and 4. Okay, so I just factored. Now let's cancel. The x plus 4's go away, and we just have x minus 4. Okay, so let's see. Step 2 said if you got a 0 in the denominator, we did. Then you factor, we did. Cancel, we did. And now you plug in the x value again. So we had a -4 we were dealing with. So let's plug in -4. So -4 minus 4 is hot dog, -8. So even though we thought there was no limit because there was a 0 on the bottom, once we factored and canceled, we were proven wrong. Okay, let's go over if you still get a denominator of 0. Okay, if you still get a denominator of 0, we use a calculator. Darn. Okay. So, let's see here. If we look at these 3 problems, they say as x approaches 2, 2, 2, 2. Well, if I plug in a 2 into this denominator, I'm going to get 2 squared minus 4. And that's 0. And that's bad to have if it's in the bottom. And that is in the bottom. X squared minus 4. So I try and factor. And if I factor, the x minus 3 stays on top. But the bottom is a difference of 2 squares. Like what we just did, with x's and a minus and a plus. But if you remember, the 2 numbers that multiply to 4 that are the same numbers are 2. Okay, so here I tried to factor, like number 2 said to do. I tried to cancel, but I can't cancel anything. So because I can't cancel anything, I'm still gonna get a 0 in the bottom. So instead, we plug it into y equals. So let's plug this baby into y equals. And I think I did this on another video. But if you have a new calculator like me, you can press this green alpha and this top left y equals, and then press this enter at the bottom right. And it'll pop up little boxes for you to just type in your equation. On the top, x minus 3. The x is right here by the green button. And then go down, and we have x squared minus 4. And then I could keep going. But if you don't have a new calculator like me, you can just use the old school divide sign to show the fraction, but make sure you put parentheses around the top and the bottom. So I'll do it the old school way. I'm gonna put x minus 3 first, but first it needs to be in parentheses. So parentheses, x minus 3, parentheses. The division bar means divide sign. Parentheses, this x squared minus 4. Okay, and then I'm gonna press graph, and our graph is probably gonna come out looking janky, like these ones on the front with all different pieces, and they look a little odd. Yeah, okay. So we're going to press graph, and mine looks horrible because I'm zoomed weird. So let me just press zoom standard number 6, and it'll take me back to normal. Ah, here we go. Okay. All right, so here's my picture, and it says as x approaches 2 from the plus. That means from the right of 2, remember? 2 with a negative means the left. 2 with no symbol means both. Okay. So let's look at this picture. Where is 2 at? 2 is like right here. So as I come up on this x value of 2 from the right, let's see what happens. As I come in on this curve and I get closer and closer to the x value of 2, my graph goes all the way down to negative infinity. So we'll go over that again. As you come in from the right and get closer and closer to x equals 2, you go all the way down. So the limit for x approaches 2 from the right is all the way down, or negative infinity. Okay, let's look at from the left. So as I'm coming from the left, it looks like I follow this curve and I go down, but that's not where I stop because I'm supposed to approach 2. So I keep coming in from the left. Okay, let's look at this curve in the middle. As I get closer and closer to 2, I'm getting about, oh, look, here's an x value of 1. As I get closer and closer to the x value of 2, the curve goes up all the way to infinity. So as this curve gets closer and closer to 2, the y value goes up to infinity. Okay, then for just 2 straight on, remember you look at your previous 2, and if they're different, you write does not exist. And mine were different. Okay, yeah, that's how you look at your calculator. Okay, let me show you how to zoom in or out. If you want to zoom in or out, you kind of already saw me, but you press zoom, and then you can press 3 for zoom out, and a little spider comes up that's blinking. You just have to press enter, and it zooms it out, and you can do it over and over. And if you ever get to the point where you don't know what your graph looks like anymore, you just want to reset it. Press zoom 6. 6 takes it back to the standard normal graph. Okay, so again, if you want to zoom in or out, you press this button. Okay, let's look at how to find the limit of a rational equation and remember, rational means like these fraction equations, as x approaches infinity. It says we have to use the same rules as horizontal asymptotes. Well, CARP, we haven't learned those. So let's look at this horizontal asymptote business. This horizontal asymptote business says this is from college algebra, and you look at the highest exponents of the x from the top and the x from the bottom. That's called the degree. And if the exponent on top is smaller than the one on bottom, your asymptote is y equals 0. If your exponents are equal, you divide the big fat numbers attached. If the exponent on top is bigger than the one on bottom, you say none. So let's look at these 3 examples. If I look at this first one, the highest exponent on top is 1. The highest exponent on bottom is 2. So that means the exponent on top is smaller than the exponent on bottom. So we have small over big. So small over big means small over larger, y equals 0. Every single time. Every single time. So if your exponent on top is smaller than the one on bottom, it's y equals 0 is your horizontal asymptote. Okay, let's look at this sucker. This one has an exponent of 2 on top and a pretend 1 on bottom. So that means the top sucker is larger and the bottom is smaller. Well, let's see, what does that mean? Larger. Oh, here it is. Larger over smaller. That means no horizontal asymptote. Darn. Okay, let's look at this last sucker. His exponent on top is 2. His exponent on bottom is 2. So that means those exponents are the same. So you divide the big fat numbers attached. I don't mean this 3 and 5 out to the side. Those are called constants. We want to divide the coefficients, the numbers that are attached, as in this 3 and this pretend 1. As in, my asymptote is y equals 1 from the top divided by 3 from the bottom. If I could reduce, I would, but you can't, so I'm just going to leave it 1/3. Okay, so now let's go back up to this. How to find the limit of okay, it's the same-ish rules as a horizontal asymptote, but there's something special that you do if no horizontal asymptote exists. So, if the question was, what's the limit as x approaches this infinity of this f of x? The answer would be 0. If the question was limit as x approaches negative infinity, the answer would be 0. For this sucker, this equation, if it said limit as x approaches positive infinity, or if it said negative infinity, the answer would both be 1/3. So the limit and the horizontal asymptote turn out being the same thing. The only difference is here, when the larger exponent is on top of the smaller exponent. When this happens, you have to do something special. And when that happens, you have to do this specialness up here. It says if no horizontal exists, then plug in what x approaches into the leading terms of the top and the bottom. What the heck? Okay, so let's look here. My exponent on top is bigger than the one on bottom. Poop. So that means I'm going to plug in what x approaches into the leading term. The leading